So we're going to look at borrowing money, an ordinary annuity. Remember the difference between annuity due, which is what we looked at the other day. An ordinary annuity is when the payment is made, whether it's at the beginning of the compounding period or whether it's at the end of the compounding period. So the difference would be our future value. Can we see what the subtle difference is? Right. So the first term is P instead of PR, and it goes up to PRN minus 1 instead of PRN. So our future value, again, if we wanted to use a formula, well, essentially it's just our geometric series formula. P is the principal, interest rate plus 1, N being time periods. Now, if we wanted to work out a present value then, the formula we'd come up with would be thus. We can't just quote those formulas, we need to derive these things. So let's look at the loan repayment question. So the amount still owing after N time periods is always, just keep this one key idea, the amount N, so the amount left, is principal plus interest minus instalments plus interest. You see, you can think of a loan as two different investments. Right? So if you're going to lend me $100, it's like saying you're making an investment in me. You're giving me $100. You're investing $100 in me, and it's going to be in compound interest, whatever the time periods are. I've got to give you some interest back for that investment. But the repayments I make can also be considered as an investment, because now I'm giving you money. So it's like me making an investment in you. And eventually when the contract's over, your investment and my investment cancels each other out and everything works out. So let's look at this one. Richard and Kathy are borrowing $20,000 to go on an overseas holiday. Well, not this year, they're not. Interest is charged at, 12% per annum. Go look somewhere else. They start repaying the loan 1 month after taking it out, and their monthly instalments are $300. So how much will they owe the bank after 6 years? Okay, so the initial borrowing, so that investment, the bank is investing in Richard and Kathy, they're giving them the $20,000 and they've had use of that for 72 months. So the interest rate is applied for 72 months. So say, the repayments are also an investment. So the first repayment is like saying, I'm going to put $300 in the bank and invest it for 71 months. But then a month later, I'll put another $300 in the bank and invest it for 70 months. And so on, and so on, and so on. So the second last repayment will be invested for 1 month. So the last one in this case will be invested for no months, because once I've made that last payment, we're done. Amount will be the difference between the two investments. So the first one just ends up being a compound interest, the amount I've borrowed. The second bit becomes a geometric series. So sub it into our formula, crunch the numbers, and we get that there's $9,529.01. So how much interest have they end up paying in that 6 years? Well, they've made 72 repayments of $300. So they've given the bank $21,600. They've reduced the loan from $20,000 down to $9,529.01. So they've reduced it by $10,470.99. So the interest must be the difference between the two, because they've given the bank $21,600, but the bank has only reduced the loan by $10,470.99. Where's the rest of the money gone? Oh, that must be the interest that you've paid. So they've ended up paying in those 6 years $11,129.01. And you bet that bank will chase you for that 1 cent too. Okay, let's vary the problem up a bit. Say we wanted to work out how much of a repayment we want to make. Because maybe we know how much we want to borrow, we know how long we want to take the loan over, but how much? So Yog is going to borrow $30,000 to buy a car. He's going to repay the loan in 5 years. He said, okay, 5 years, I'm going to do it. 9% per annum, so how much do I need to repay? Let the monthly instalments be M. All right, so we know that initial loan, $30,000, there's the investment the bank's making in me, and that's going to be in there for 60 months. My first repayment, well, I don't know what M is, that's what we're trying to work out, but whatever that is, I'm going to give that to the bank and it'll be there for 59 months. Then the next one there for 58 months, and so on and so on and so on, until we get to the last one. And so I'll just give them the last repayment. Same idea, principal plus interest, minus all those instalments plus interest. What's the difference? Amount 60 though, we know what that's going to be, because that's when the loan's finished. So that must be 0. So there's the equation we have to solve. We've just got to make M the subject of that. Again, bit of number crunching. There we go. Monthly repayment of $622.75. Well, what about, I know how much I can afford to pay back each month. I know how much I want to borrow. Put that together then, well, okay, what's the length of the loan I'm going to need to do that? How long am I going to have to take to pay it back? So this one comes from an actual HSC. The council has borrowed, what's that, $3 million at the beginning of 2005. Interest rate, lovely 12%. That's nice. Each year, interest calculated on the balance, etc., etc. The debt has to be repaid, equal repayments, $480,000 a year. Show that. So in this case, you've got to come up with the expression for A2. All right, so that initial investment is going to be there for 2 years, because we want to know amount 2. So we'll make one repayment that'll be in there for a year, and then there'll be a second repayment. So there's only going to be 2 repayments on this one. Principal plus interest, minus instalments plus interest. Now, look at what we want to prove. Okay, they've used scientific notation, common factor, I think we've got it. If I factorise out that, what is it, 480,000, that is 4.8 times 10 to the 5. And the 3 million is 3 times 10 to the 6, so we've got the expression. Show that the amount N is this wonderful expression. Okay, so same question, but now we don't know the length. So first repayment, N minus 1 years, then N minus 2 years, and so on, until the last repayment is 0. Okay, we don't know what N is. We're trying to find N. We want to rearrange this expression to match what they've asked us to show. Well, let's put it into the geometric formula, see what we get. Nicely, 480,000 divided by 0.12 comes in to be a nice neat 4 million. It's good, isn't it? So you can take out a common factor there of 1 million if you want to. Well, eventually. I've expanded out the right-hand side, and there we go. We get what they're asking for. So just a little bit of manipulation to get it into the form that they wanted. So when will they make the final repayment? So amount N is going to equal 0. We may as well use the expression that we've just shown. So solving that little equation, N is, eventually, there it is, log 4 divided by log 1.12, 12.2 years. So the 13th repayment will clear the debt. Oh, look at this one. This one's just from last year's paper. Tina inherits $60,000, invests it in an account earning interest at 0.5% per month. But each month, immediately after the interest has been paid, she then withdraws $800. So it's sort of like setting up a pension. The amount in the account immediately after the nth withdrawal can be determined. Now, you don't have to work it out, they've given it to you for. But by this recurrence relation, A0 is $60,000. Use the recurrence relation to find the amount of money in the account immediately after the third withdrawal. So A3 will be A2 times 1.005 minus 800. But of course, A2 is A1 times 1.005 minus 800. We can manipulate that one around. A0, they told us, was $60,000. Bit of number crunching, and there we go, we got it. Didn't bother using the geometric formula for that one, because I mean it wasn't exactly hard to plug all those numbers in. Calculate the amount of interest earned in the first 3 months. Okay, so the interest will be, well, we know 58,492.49. That's what's left in the account. But there's 3 times 800. We've got those payments. Take away the 60,000. Right, so the first bit was the balance. The second bit's my withdrawals. But then take away the principal, because that's not part of the interest. We end up with 892.49. So calculate the amount of money in the account immediately after the 94th, rather random number, but anyway, 94th withdrawal. So using that, we'll get A94, and there's our series that we want. Plugging it in, it's just number crunching. A whole $187.85 left. All right.